Okay, so welcome to the third of the BuildOn sessions. Um, so I am not showing. Okay. Do you see the opening screen now, guys?
Uh, we see only this PPT, this PDF for us build on number 3, and then there is a VS Code.
And now you see me change it to the second page.
Uh, Not yet.
No. No.
Okay, so I'm getting confused about my sharing. So hang on a minute. Let me make this full up. Okay, so you see the second page now?
Yes.
Okay, good. I was paging through the one that I wasn't sharing. Okay, so in this second session, we're getting ready to move into DirNav. I'm going to talk a little bit, not much, a little bit about my solution and things leading up to the solution. And then we'll focus on getting started with directory navigation. Okay, so I want to take a look at this thing called Design Bytes. We looked at an early version of this last time, I think. So what these are, what I did was I put together a set of structures like this. And I've written some code for each one. Now, each one of these, all these guys do, all these structure guys do, is they're counting lines. They're just a little program that you give it the name of a file on the command line, and it'll count the lines in it. That's all it does. And the whole idea is to focus on the differences in these structures. Keep the compute part small enough so that we can tell the differences in the structures. And all this comes about because we're trying to set up the TextFinder so that when we display a lot of continuing data, the user will see that as it's being generated, not only at the end. So let's go to this page where I was. Okay, so that's not what I want. Oh yeah, it's right at the bottom here. So what I did was I've written code for each one of these, and you know, I talk about what's good and bad about each structure and what changed to move from one structure to another. And where we're heading is into a data flow architecture, and then we're going to talk about some options for that, and eventually we'll work our way into the Rust part of all that. So the factored structure, you know all about that. You just create some more. It's interesting that taking this basic line counter and turning it into a factored structure with an executive and input that handles grabbing the file, and the compute, which just counts the lines of code, and the output does a little tiny display on the console. The lines of code to do that tripled. And that's not too surprising because here we had one package and one user-defined type, and here we have 4 packages and 4 user-defined types. Then we move, where we really want to go is into this data flow structure. And so instead of coupling these together so that the executive owns all 3, what we're doing is coupling this way. So the executive owns the input, input owns compute and compute owns output. So executive just creates an input object, and the input has a data member of compute, and so when he's constructed, that constructs compute, and compute has a data member of output. When that's constructed, that generates output. And we have less lines of code for this than we did for the factored structure, which I thought was kind of interesting. And now for the first time, we can see continuous output, because the executive just starts this, and the input, you know, there's just constant data flow going through this. Every time the input finds an input, it sends it to compute and does the output, and then the thread comes back. This is all single-threaded. The thread comes back and, you know, grabs another input and so on. And so we see that continuing output. It gets a little harder. So the good news is this has really nice user ergonomics. The user can see what's going on. You know, if he's generating garbage, he can stop it and so on. And we don't have this extra step of passing data back and forth to the executive. Here, the data is all just flows. All the executive does is create this guy, and then he's done. And so now we have this chain of dependencies that flow toward the output. Input depends on compute. Compute depends on output. Now, the next structure I want to look at is type arrays. Oops. And this is what I've used so far for my TextFinder. So the only difference here is that now I am making input a generic on the compute, and the compute is generic on the output. And input defines an interface that he's going to call. He defines the compute interface, and compute, if he wants to use input services, he's got to implement the compute interface. And the same thing with output. Compute is parameterized by the output, and the output now is responsible for implementing the output interface that compute defines, and so he does it. And now what happens here is that one of the interesting things that happens is that this decouples the output. This decouples each of these parts from each other. If we looked at, and we probably will, if we looked at the details of this compute interface, we'd see that it has a factory function in it. Just like C++, Rust can define factory functions in its traits. This is a trait, very like a C++ interface, very like a C# interface. But you can define a factory function. And so this guy has this template argument, and when he starts up, he just calls new on his, he has no idea what type it is. It's just my type T, but he does know that it implements the compute interface, and the computer interface has a new factory function, and so he just calls new on it, and that creates an instance of this type. So it's up to executive to declare input with the proper type, and he declares the compute with a proper type, and then and so now the data flow is still going from input to compute to output, but now the dependency chain has reversed. It turns out that output now depends on this compute interface, which is defined in this package. So output depends on this package. And compute depends on the compute interface, which is defined by this package. So now he depends on this package. In reality, both of these guys depend on this trait, not on each other. And both of these guys depend on this trait, not on each other. But you'll see in the TOML files where dependencies are defined that now the chain of dependencies goes upstream, not downstream. So for that reason, we often call this the dependency inversion. That's exactly what's happening. This is the dependency inversion principle at work. So that's really this is really a great structure for the TextFinder. And now for TextFinder, this will be dirnav. And dirnav is a really nice reusable component. You know, there's a little bit of stuff there to put together. And so you'd really like to reuse it from application to application. And using this compute interface means that he's just calling on, there's a function called doFile and a function called dodir. He just calls those functions, and he has no binding on any of the implementation details, so we can put any compute implementation here we want. So this guy can be used in a variety of different applications, as long as the type that wants to use its services implements the compute interface. You know, for dirnav, it's the dir event interface. All of that works just fine. So now this guy becomes truly reusable. We can use him in a bunch of different applications without changing any single character in his implementation. And the same thing is true here. Okay, we get that same kind of effect. Now,
hey, Doc, just one quick question for you, Doc. Your factory is inside of input, and you're creating an instance of the compute impl you're.
So compute defines an interface. Compute defines this interface, and part of it is a new function, which is the factory function. You've seen me do that in C++. You can put a factory function in a C++ interface, and we're doing the same thing. But because what he's really got here, his template type is this type, when he calls new, he's going to create an instance of this type.
Right, okay.
So he sees this type as compute, but it's really compute impl of output impl.
Yeah, so then the only requirement is that whatever type you'd want to pass in or instantiate would have to implement that new factory function.
Absolutely. He's got to implement the whole interface, not the
whole interface.
Okay,
sure.
and new is part of that interface.
Yep, good, thanks.
So it's nice, you know, I like the C++ and Rust form where you can put a factory function in an interface. You can't do that in C# or Java. They don't let you do that. Okay, the only other thing that you know, you might want to do is to use a plugin interface, and here's what's going on in this plugin interface. It's just like the type erase interface, except that I want to be able to substitute this output at runtime. Here's a use case. I built this TextFinder, and now I want to build an application that finds links on a web page and builds me a table of, so, you know, maybe it searches through all of the web pages in my site, and it builds me a table of all the links that are embedded in those pages, and then I can just go click and see if any of them are dead links. So I've got a dead link analyzer, okay? And I could automate it further, you know, have the program click on the links and all that sort of stuff. But so here I could take my TextFinder program, and with that little change, you know, just adding a little more capability here, I could have it do a much more, you know, application-specific operation with very, very little change. None of this stuff would change here, just this part. So how do we enable that? So what we want to do is, you know, for example, I may want during runtime, I may want to let the user specify what the output is, what the output processing is, okay? And I can't do that with a templated argument. So before, compute impl was templatized on the output, And that's defined at compile time, so the user can't change that at runtime. But using this structure, now the user can enter an argument on the command line that says, I want more detailed output. And we can substitute in this different output object that gives the kind of details that the user wants. Instead of trying to embed 7 different schemes for generating different kinds of outputs in one thing, it gets complicated and messy and hard to manage and hard to test and so on. We can just have little objects, simple little objects that we can substitute at runtime. So the way that happens is we got to remove the generic argument from compute, because we don't want to specify at compile time what output he's using. So we remove it. And now the question is, how does he get access to it? As before, compute has to implement, compute impl has to implement this compute interface that's defined by input. And all of the different outputs have to define the output interfaces defined by the compute. All that's the same. But now we got to get this output argument to compute. And the only way the executive he has access to input. So what I did was I had input return an instance of this compute object. Okay. And this compute object has a plug-in interface so that I can just take this and plug it right into compute. So if I have my hands on compute, I can plug whatever output I want into it. We'll see how that works in a minute, okay? So it's a little more, so now, it's a little harder to understand and maybe a little harder to maintain, but a lot more flexible. It's a little more complicated, a few more lines of code, because we have to give executive access to compute through input, because all he has is input, and we've got to provide the plug-in interface. Okay. Now what I've done here is for each of these, for example, in plug-in, I have all the code for it. Okay, and we could look at it. So for example, here's my input. Can you guys see that? Is that big enough for you to see?
It looks good, Doc.
You see that okay, Mike?
Yeah, it looks good, Doc.
Okay.
Yep.
So am I going too fast, or am I leaving people behind?
Good for me.
Okay.
It's okay.
So here's what I did on the input. I just provided a simple little function called getApp, and he returns a mutable reference to self-compute, because I want my executive to be able to configure compute with a new output. So it's got to be a mutable reference, okay? And he's got the compute is right here. Here's compute, and notice it's just a T type. He doesn't know what type it is, okay? But he does know that that compute provides this new function, because the that's part of the compute interface. Okay, so here's the compute interface that he defines. Here's what input has provided for compute to use. It's this trait. It has a new function. That's what we just called down here. And Rust wouldn't let us call this unless we told it, yeah, that's part of the interface. C++ would let us do that. And then we can substitute a type in, and if the type had a new function, everything would be great. Rust won't. Rust demands that you, just like C#, that you convince it that it has that function to call. And then my doCompute function, and post-processing, I can get the line. This is the lines that I've evaluated. So anyway, this is how this getApp is how the executive gets his hands on the compute interface to configure it with the output. Okay? You with me, Gav?
I have a question, Doctor.
Sure.
So the plugin that you have implemented at this the last stage of dependency at output.
Yep.
Can that be can abstract factory be an alternative to that solution too?
It has a factory, but see, so that's a good question. You're saying, why don't I just say I can't have compute use just the trait. Compute has to be in order to use the output, it has to be instantiated on that object in order to use the factory. If he's not instantiated on that object, all he has is a reference to the interface, then the compiler doesn't know how much space to allocate for this, because if he is parameterized on just that interface, then that isn't the amount of space this guy takes up. So the compiler can't lay out the class just based on that interface information. It has to have a template type.
Okay.
And we're trying to get rid of that template type. So that's why that doesn't work. That's why we have to go this extra, and that takes a little while to get your head around. You're probably going to have to think about that a little bit. Let's go down and take a look at, by the way, I'm using modules here. I'll talk about it in a minute. Samuk had a nice little reference on modules that he posted. So,
Doc, just one real quick question, if I can. You hand off, you have that get at function where you return a mutable reference. That would mean if you hand that back to the executive, now if you wanted to do some more processing, you wouldn't be able to, right? Because there'd be a borrowed reference. And the code that would do input wants to mutate that. And
that isn't correct, because what happens is he's turning this reference. He's returning a reference for the executive to configure the output. Once that configuration is once that configuration is done, the executive leaves that scope, and the reference then is okay.
Oh, sure. Yeah, I got
you. You make a really good point. You got those things can bite you. The compiler will tell you about it, but they can bite you when you're laying out these a little slightly more complex designs. I'll come back to this module in a minute. This is a Rust module. So here's the compute. Now he's got to provide for this plugin. So this plugin can't use a new function for the reason, really, it's due to the reason I just talked about with Vabehav. The compiler can't figure out how to lay out space for it. So it turns out that the compiler will say that what we're really doing is something the compiler calls a trait object. That's what a plugin is, a trait object. It's an object that's defined to the plugin only as a trait. And trait objects can't have any function that returns self. It has to do with safely laying out code for that object. Okay, and now set output. Here is my plugin. So this compute now has a function that the executive is going to use called set output, and what he's accepting is box dyne output. And let me talk about that a little bit. So output is the trait, the output trait. It's the interface, okay? And dyne says, dyne is a data structure that holds a pointer to the data, whoever implements output, and to a virtual function pointer table that maps to his functions. It's the old virtual function pointer table stuff from 687. You guys remember that, okay? So dying, really, what's happening here is that where C++ associates a virtual function pointer table with every class, Rust associates a virtual function pointer table. Well, that's not true. It really does with every class too. Now, box, what's happening here is I'm using box. Box means I'm putting this on the heap, and box is a pointer from the heap. This will, this is saying, here's a pointer to something on the heap. Here's a pointer to this trait object on the heap. And the reason I'm passing it as a pointer is that it avoids getting into lifetime issues. If I could pass this in as a reference to a dying object, no box, just reference to a dying object, but that would cause the compiler great concern about whether this output was going to go away before my host was done using it. And so it would make me annotate lifetimes all over the place. I can avoid all that simply by putting it on the heap, and so now the compiler knows that guy isn't going anywhere until compute impl goes out of scope, because that's when box goes out of scope. So what's happening is we're moving this pointer into here, okay? And so he's now right here. Notice that my out is an option of box dying output. And it starts out with none. Remember, I can't have an undefined pointer. Can't have an undefined reference. See, Rust won't allow that. So that's one of the major uses of options, to allow me to reserve a way to hold on to a reference later on that I can't define right now. So I have this option, and it starts out as none. Okay. And now in this set output, okay, now self.out.replace, I'm replacing that option, the none, with out. You look puzzled, Mike. I can't hear you.
Sorry. No, I'm fine. Just kind of.
Okay. Vaibhav, how we doing?
Doing good, Dr. Fawcett.
Okay. Simuk, how we doing?
Simuk actually left. He had some issues at work, so he left.
Okay.
He'll be watching the video.
All righty. So, anyway, so that's the way that works. So again, the story is that the executive is going to call getApp on the input. The input gives him this compute, and then he plugs in the output into this set output. And not only is all this code here, and here's, by the way, is the output, and not much here. Not only is all this code here listed in text form, but I've also put it up in a repository. Well, I'll show you where that is in a minute. So notice here that my output depends on compute, and my compute depends on input, and my input doesn't depend on anybody. That's the dependency inversion principle at work. Okay, so this, I've summarized this. What I'm really pushing you to do is to implement either the type erase or the plugin, and it's not a big deal. The only reason for going the extra complexity of the plugin is if you want to reserve for later on a really easy way to change the output processing. If I were in your shoes, I would probably implement type erase because it's simpler. Okay. you don't have, the executive doesn't have to get at the compute through the executive doesn't have to reach through the input to get to compute. And, you know, so it's just a slightly simpler. All right. So now let's go take a quick look at my text search solution. So my text search solution is here in Jim Fawcett BuildOn, and this is my solution, and this is the demo code, you know, the starter code for text search in DIRNav. So, you know, if you want to get your hands on the starter code, that's right here for DIRNav. Rather than look at that here, I have my text search right here. I think this is it. So let me go back to that. I have in my solution to step 2, I have a DIRNav, but the only thing that's here is I put in DIRNav, I don't really have a DIRNav. All I have is this trait, dir event, and a little helper function replace separator that really belongs with a DIRNav kind of code. I don't have any DIRNav code at all. But I wanted to set up the structure so it was easy to plop DIRNav into here. So I could have moved this stuff directly into text search, and, you know, which you probably did, and that's fine. But so, you know, here's my solution. So here's my search event. This is text search, and so he's declaring the trait interface search event for the output. Just saying, output, if you want to use my services, you got to implement this. And now this is the trait that you know, he's going to implement from DIRNav. And by the way, in this version, this is set up to be type erase, not plugin. So I'm not using a trait object here, and so I do have a creational function in my output. Okay, just because you know, in this solution, you know, where what I did in my solution, my complete solution was I did a type erase rather than a plugin, and so, you know, I have a finder, and its directory is a path buff, and its text is a string, and its output is this type T, okay? And he's going to implement it himself. So, you know, here's my implementation for the finder, the text search. He's got to implement dir event, okay? So here's implement T. T is constrained to be a search event. In other words, this type, finder's type, has to implement search event. The output has to implement search event. And now I am implementing dir event for my upstream component, you know, which I'll have in the whole solution. And so I have a new self dir path buff from dot. My default is just a current directory, and an empty string, and an output. Whatever you are, just create a new instance of yourself. Again, I couldn't do this if I was using plugin, but for this type erase, this works fine. And then I implement do dir and do file, okay. And now I'm implementing set text, and this is this function allows the executive to set the text for me, or if you wanted, you could set the text on the dirnav and have it pass it on. I don't like that solution simply because that starts to pull application detail into dirnav. So anyway, there's a way to set the text that the finder is going to look for, and then a getApp function, and a little bit of testing, in this test harness. So here, if I said cargo test, it's running these tests, and it says, okay, yep, you passed the tests. Okay, so that's my solution. I'm not going to talk any more about it unless you have some specific questions. So, we can talk about it at the end if you have specific questions. I want to look at dirnav now. So this is what we're launching on. And so now we have Finder that implemented dir event. You just saw me do that. And Finder defined search event. And now we're going to build dir event that uses Finder and defines this dir event for Finder to use. Okay, so now Finder will depend on a dirnav just to get at this event. And here's a little pseudocode for the dirnav. As soon as you enter the visit function you call dodir, now you find all the files and do file on each one. When you find directories, you just save them, because you want to be done with all the files before you move to the next directory. You want to get, and there's no guarantee that the directory system, the directory from the standard library will return all the files first before the directories. Normally it doesn't. It gives you a mix of what, based on their creation time, I think, or something. But anyway, so we want to make sure we do all the files first, because once we dive into the directory, we're going to display that directory, and we don't want to pop back up and then show some more files as if they belonged in that lower directory. So we find all the files, we display the directory, find all the files, and then we move down to subdirectories. Okay. And notes about the interface, and here's basically, you need to be comfortable with the strings, path buff and path. We use just a little bit of that for search. You're going to use a little more of this in dirnav, and you'll find these are useful resources for that. And the starter code. So, just like before, I gave you a little bit of starter code. A little less this time, but I've set up the structure. So here's impl dirnav, where T, so T is the type that I'm going to be instantiated on, the text search, Finder. And Finder has to implement that dir event. And then, I implement the new function, which was part of that. So I implemented, I'm not implementing a trait here. I'm just implementing all my own stuff. I implement my own new function, a getApp function. This allows the executive to get at Finder to configure them with the text. So the executive will create an instance of dirnav, and as soon as he's created, he'll call getApp, and he'll configure that app with the text. And I think this has to be, No, it doesn't, because I'm not changing. Yeah, this is okay. Okay, and now this visit is where all the main stuff that you're going to have to do. It's not the only place you're going to have to put code, but it's the main stuff. And I just have a little silly bunch of pretending to search some directory tree and put that information out. And I've got some tests for it and so on. So that's the dir nav. And I've given you a reference to the type erasure and, you know, this code behind all this. If you go to this, you know, bad link. Mike, at the end on Discord, just send me a message that in the dir nav references, I have a bad link to type erasure.
Yep.
Okay. Any questions about the starter code? Okay. So a fair amount of what you're going to do, you have to start getting comfortable with error handling. So let's go look at the error handling. We looked at this first one last time. Let's look at this one. There's actually several things that I'm going to illustrate with this example. This has nothing to do with error handling, well, only indirectly with error handling, and it has nothing to do with dir nav. What I'm demonstrating is that scopes have values. Every scope in Rust has a value. That's not true of C++. So the value of the scope is the last expression. So the value of this scope is 5. And here, assert v1 equals 5. So, you know, look at this. I say let v1 equal, and I assign v1 to the scope. And what that's saying is that v1 is equal to the value that this scope returns. If I don't have a semicolon here, it's going to return a value. And Rust uses that a lot. Let v2 equal, now here, let s equals a string slice, and now I'm returning s, and assert v2 equals a string slice. Okay. And now I added a semicolon here, exactly the same expression. The only thing I did was I inserted a semicolon. Now, what that means is there is no expression in this. There's a statement, but no expression in the scope, and so it returns nothing. The unit, this signifies nothing. It's the unit type. Okay, cool. So, and that's used in a lot of places in Rust. You know, you've seen it in some of my code, you know, as we went along. Now, I want to demonstrate option. We're going to talk more about options in a little bit. So I have a sum function. I want to sum over this vector. And here's a very, very typical use of the option. This vector may be empty. And so if it's empty, I return none. That's a perfectly valid value for this option. Otherwise, I construct an iter, and there's a function sum for the iterator. Iterator has a whole bunch of adapter types functions, and sum is one of them. There's also a prod. You know, we talked about that the last time. So I calculated the sum, and now I return sum of sum. I have to wrap it in sum because I'm returning an option. Okay. And let's run it while we're at it. So demonstrate option, down here in main, there was nothing. I was printing out nothing. It's here because if I change it, then I'll get an error. But now here, demonstrate option let vec. So here's a new vec, and now I say let option equal sum of this empty vector, and I should get none. If op is none, print out no content of sum. And now I give it some values. Let opt equal sum, and if it is sum, display it. And sure enough, here's the vector and here's the sum. Option unwrap. I know it's safe to unwrap because this is sum only returns true if it has, you know, the option is a sum. Okay, now, and there's a result. So now I'm going to demonstrate some error handling result. I'm using the file system. I'm using IO prelude. This gives me access to some of the IO stuff, and standard IO result. Now, one thing let's take a look at. Notice that results, the standard result has two template parameters. It has a parameter T and a parameter E. This only has the T part, file. And the reason is that the standard IO defines type result of T equals standard IO result of T and E. And the reason is that E is always in standard IO is always the same. It's standard IO error. What's really here is, this is, let's type it in. This is really, is standard IO : error. Okay, so when you see this result with a single argument, it's because it's a standard IO result which has just been defined. This is like a C++ uses. This is just a type substitution. It's just saying the name result T stands for standard IO result of T and this concrete type, standard IO error. Okay? So, and now I'm trying to create a file. And now what happens is this create function returns a result. And this question mark is really it's a macro operator, try operator. And what that does is, what try does is, if create returns an error result, it returns the error part, you know, ERR rather than OK. If it returns error, then it just immediately returns from the function, returning that error here. That's what question mark does. If it's OK, if it succeeds in creating, then it just binds it to file. So it's already unwrapped and it binds it to file. So you don't have to unwrap it. You know, this is really nice. And now I've got a file write all that also returns a standard IO error, and I can do the same thing. I call these UOB, unwrap or bubble up error. Okay, that's a UOB. Okay, so, you know, and I just, you know, I pass in a string of content, and I just write content out as bytes to the file. and then I return OK. I know this succeeded because I didn't return, so I can just return OK file. Now, this works great. So I've replaced 2 error handling bits of code with nothing but 2 question marks. That's a really nice simplification. That only works if the error that I'm trying to return is exactly the same. It's got to be exactly the same error. You know, I could have some other an error from something that wasn't a standard I/O error, okay? As long as these 2 have the same error and it matches the type of the error in the result, that's fine. But if you're returning 2 different types of error, the compiler won't compile it, says you got a type mismatch. One of them has to mismatch the type that because you can only specify one, okay? And, you know, there's things you can do. You can put a wrapper around this that transforms the error into, you know, into the kind of error you need. And, you know, there's a bunch of kinds of things like that. So, nice way of handling and bubbling up errors. Open file and read. Okay, same thing. Result of string, standard I/O result. Let mute file equal file open with a question mark. Let mute buff string equals new. File read to string. Okay, so here I created a test file, and now I'm just reading it and reading it out as a string. So here I let file name equal new file text, let content equal first line, second line, attempt to create the file, you know, and then so, you know, I'm just illustrating all of that, and here's the here it is running. So, and the interesting thing is the playground, you can write files to the playground and read them back out again, which is a little surprising, but it does work. Any questions about this error handling before we leave this? Okay. Okay, now I'm going to come back to this iterating over generics. Let's go over this now. Go over it in order so I don't. So here, you know, what I'm going to do is I'm going to iterate. Let's just run it so we can see what's going on. I demonstrated something very like this in the last time. And we're just going to take a quick peek at it as genericness. So here I'm iterating over an array. I'm iterating over a string. I'm iterating over a string slice. I'm iterating over a byte array, iterating over a vector, iterating over a hash map. So, yeah, very common things that you might want to do. What I'm doing here is there is a standard crate called any, and in it, it has a type name function, and this will return the name of t, whatever it is. And so here I insert t by reference, and now I'm getting the type of t, not the type of little t. The type of little t would be the reference to this type. And I have an underscore because I'm not using this t. If I didn't have this underscore, the compiler would natter at me with warnings about an unused variable. So I can avoid that just by using this underscore because I know I'm not going to use it. I'm not using it anywhere in this function. So, you know, it's just a nice way of getting the name of the type. And that's what you see here is type is and string, you know, byte, vec, and so on. And I'm showing the type, let s equal type is t, and I'm printing it out. Type is. Could have done that in one line, but. Now, this is a basic iteration, and what an iterator really does is iterate anything that satisfies the iterator trait So notice that this is a function, doIter, that's accepting an iterator. And this T has to be an iterator. So I have to have satisfy the iterator trait. I'm going to display it using a debug format, so it has to implement debug. And the item that's returned has to satisfy debug, because that's what I'm returning. That's what I'm printing out here. Actually, I could probably remove this and it would work. This is the important thing right here. Okay, so now I loop and let item equal iter.next if item is none. So what happens here is this iterator returns an option, and the option is none if I'm all done with the iteration. So if it's none, I break. Otherwise, it's an option. And now I'm going to unwrap it here. I know it's safe to unwrap it because I know it's not none. If it was none, I would have broken out of the loop. So it's safe for me to unwrap it. And, you know, so, you know, that's the kind of thing that's happening here. And in fact, a for loop really is this kind of a loop. So I'm told that the for loop is just a syntactic sugar over this. Here's, you know, here's the same thing with the for loop. For item T in print item. And this does all the dereferencing, you know, it does the unwrapping and all that sort of stuff. So now I am going to show the type. So here's my array. I create an array. I show the type of the array. And I do iteration using my loop. I do iteration using the for. Same results, of course. And then iterate over the string. Okay. And so I show the type. Now I'm iterating over the characters. Remember that strings are UTF-8, and so each character, you can't count on it all having the same size. They don't. And so you can't index it. There's no indexing function for for strings. And so we have to use this chars iterator. This is an iterator. And now I do iterator with schars and do idiomatic with sbytes. And so here's the chars that I'm, you know, using with my do iterator function. And here's the bytes that I got out of the, this just converted, this just told Rust, treat this string like an array of bytes. And I can iterate over slices, so let slice equals 2, so I'm skipping the first couple of characters. Okay, where am I doing that? Iterating over string slice. Oh, this was a string, so I'm skipping A and I'm skipping the space, and now I get string. So that's what this slice is doing for me. Slices are really nice, used a lot in Rust. And here I'm taking a slice of that string as bytes, just saying, display it as a bunch of bytes. Really, it's the same thing I did before. And I did it for vector, did it for hash map. So anyway, that's that.
What are you doing in that line where you were doing the address of star bytes there? That was a kind of a cryptic line.
So where are we? So are we at the output are you looking at, or down in the?
Down in the code, right there on line 85 or 79.
79. Ah, yeah. So what I'm doing here is bytes. Here, let's go look at the idiomatic thing. So notice that I am passing by value this type in.
Mm-hmm.
Okay. So now what I'm doing here is I am taking a reference, so I'm passing this reference by value, but I want to get at, so this takes me back to the array of bytes, and this dereferences that byte array to let me start iterating over it.
Mm-hmm.
Right? Some of this, Rust very often does some of these kinds of things automatically for you. It might here. I don't remember whether it does or not. Let me just, for fun, let's see what happens here. I'm not sure this is going to work. But the error, so here, okay. So, okay. Yeah, so it's saying, hey, this isn't an iterator. Okay, so this ampersand ampersand thing is my slice of the array. And now I took a reference of it and it says, you're passing it in this function expecting an iterator, and that isn't an iterator. So it's to tell Rust, you know, this is an iterator. Does that make sense?
Yeah, it does. I think you modified 77 though instead of 79 in your marking.
I modified
Yep.
show type, right? So show bytes.
It's interesting your use of 2 stars though. That's the kind of I can see where you're referencing it there.
Well, so what's happening here is the array has an into iterator function.
Yeah.
It's into iterator. And so I got to get down to the array. What I'm really passing in here, look at show type.
Mm-hmm.
Show type is ampersand ampersand. Okay.
Mm-hmm.
So, okay. So what I'm doing is, what happens is this guy here implements into iterator. So I got to get down to where I can get to that into iterator. I got to tell him, I want you to take the iterator of this bytes array.
Mm-hmm. Yep.
That's one of the few places, this is a little bit obscure. Most Rust code is not, but this is a little obscure.
Mm-hmm.
But that's why I've displayed these types, so you could see what's going on. So I could see, so I could understand. Okay.
Yep.
Is that squared away?
That helps.
Yeah.
So
Go ahead.
Sorry, go ahead.
Thing.
Yeah, so like we're giving, so because the reference byte, the type is reference of U8, so we put like in 79, we put 2 star here. So the type of reference star bytes will give us like array of U8, right?
Yeah, and that has defines the into iterator function.
Okay.
Which
Okay.
Rust will
That's,
call.
yeah, that does make sense because like you pass the parameter as by value, right? So like
Yeah.
by this way, like we can
Yeah,
like
I'm
pass
passing it in as an iterator, and so I got to give it something that it can interpret as an iterator.
Yep. I see the association. You got the 2 ampersands and you've got the 2 dereferencing operator stars to complement that to get at that data. Yeah.
Yeah.
Exactly.
Can we try just put 1 star here in 79, like without just 1 star? Is that will give us like correct type? 1 star, no reference. One star, no.
Just 1 star.
Yeah, no reference, 1 star. it will give us like a
maybe
venue type. Yeah, it works.
Good for you. Yeah. Okay.
Yeah.
So that gave me, so bytes is a slice. Yeah, sure. Yeah. So what Zing is saying is bytes is a slice. And so when I take this 1D reference, that's giving me this guy as bytes. And so Rust will apply the iterator for that.
Yeah.
Thank you, Zing. Good.
Yes.
Yeah.
Mm-hmm.
Great.
Cool.
Okay. Now, I want to talk about dynamic dispatch. This gets back to, relates to the plugin. So here, traits can act like interfaces, define a function, and they also act like constraints. So here, I won't compile unless T implements this debug constraint. But here, I'm going to use this interface, and let's look at it. So let's just go to the code, because that may be a little easier to see. So I've defined this trait, speaker, salutation, okay? And he's just going to return some string, like hi. I have a presenter type that implements speaker for presenter. Okay, it implements this trait for this type. Hello, today we will discuss, he's a presenter, he's presenting a slideshow or something. I'm the presenter today. We have a friend who has a name, and now impl speaker for friend, salutation self string, let mute s equals string from, hi good buddy, it's me. And now I want to append his name to hi good buddy, it's me. So I say, let name equals self.name as str. This is a slice, string slice. And now I push it onto the string. Surprisingly, string doesn't have an add function. You can't add one string to another. All you can do is append. You can't append one string to another. You can append a literal string onto a string. And that's what we're doing here with this push. So I just take my real string, turn it into a literal, turn it into a slice, and then push it onto the string. So I just added the name, whatever this friend's name is, I added it to that. And now I implement new for that friend, and I just have his name in the constructor. That's how he gets his name. And finally, I have a team lead, implement speaker for team lead, salutation of self. Hi, I have a task for you. Okay, and now we're going to do some polymorphism. Let presenter equal presenter. Let Joe equal friend. And I don't need all these, I could have dropped them. I just did it for clarity. Friend equals new, Joe to string. Friend equals new, Sue to string. I got two friends, Joe and Sue. And let team lead equal team lead. And now I'm going to create a vec of trait objects. That's what this is. And dyn of speaker equals vec of new. So vec is going to hold these trait objects, and now I just push them on. Push presenter, push Joe, push team, and I say for speaker in v.iter, speaker salutation, well, let's do it. Hi, today we'll discuss presenter. Hi, good buddy, it's Joe. Hi, good buddy, it's Sue. Hi. So polymorphism in action. Yes, you can do polymorphic designs in Rust. Okay, so cool. And this is very much related to what we do with the uh, plugin. The only difference is I'm putting this in a box. And if I did that, I would have to box each of these, and that would work just fine. But the reason I put it in a box there is the environment that I was using it. Rust would be worried that the trait object would go away before the host, while the host was still trying to use it, and so it would have made me annotate it with lifetime annotations, which is kind of a pain. You know, it'll lead you through it. You can do it. You definitely can do it. I did it in one of my options. I showed it to you last time, and if we have time, I'll show it to you again. But here, it's clear that you know, this use is going to be all done before these guys go away, and so the compiler is very happy with this. You know, it doesn't make me put these in boxes. It doesn't make me annotate their lifetimes. Trait objects. Okay, how are we doing? Everybody doing okay?
Yes, Professor.
Yes, Professor.
Okay, Rahab, you doing all right?
Yes.
Okay, let me pull everybody up here. So, okay, and I know Zing's doing okay. How you doing, Vishtas?
Doing all right, Professor.
Doing all right. Arpit,
Yes.
your sound is off.
Yeah, I was on mute. Yep, all good.
Okay, good, great. All righty.
Professor, I noticed in the previous example, the iterating over generics part, there was some functionality you put between vertical bars. Are those anonymous functions or something?
Oh yeah,
lambdas?
yeah, sure, Vishtap. Let me go back to that. That was in iterating over generics, right?
Yes, I think lines 48 and 50.
Yeah. So here, this is a generic. I'm not taking any closure, I'm not taking any arguments, and I'm not using any closure. I'm just printing a line. I get tired of typing the semicolon sometimes, and I just, you know, and put message. Okay. This is taking an argument and then displaying it. So it's just an anonymous function.
Okay. Thank you.
All righty. Let me see if I can go back to. Okay. All right, so I want to talk about enumerations. And I've got an example of custom enumerations and matching. And let's just do it in, I've got, these are the same things we were just looking at, but in the playground. So here I created an event. I'm just making this up. I created an event of T with normal of T, warning of T, critical of T, and no event. And I'm just going to use T as a counter. You know, this is event 1, event 43, event 362, whatever. And I can implement methods on an enumeration. That may seem odd, but you can. Remember that result is an enumeration and option is an enumeration, and we have things like unwrap on result and option. I'm going to do the same thing here. Implement event T, the function unwrap, and it's going to return a reference to T. If let event equals normal, then T is just going to be the EV, the inner part of that object. If it was 3, it'll return 3. Else, if let event, by the way, this if let is a matching statement. This is not an assignment. When you see if let, that looks a little weird. this is really a matching statement. So I say, what it's saying is, if this guy contains, I'm not pulling out, there's a word for it, normal of EV, then that's true. Otherwise, it's not. So if it's normal, just return the EV, because I'm not going to do any of these. It'll just drop out. And remember, I showed you the scopes. The value of the scope is the EV. Okay? So else if let warning, return self, event critical, return self. Otherwise, no event, panic, because I don't have anything to unwrap. So it's, pretty much like the normal panic. And so now in main, let E1, and now let's run it. So let E1, here I'm just creating some events. E1 is normal 1, E2 is warning 2, E3 is critical 3, and there's nothing, these could have been any numbers at all. This could have been 100, this could be 2,000, this could be 3 billion, it doesn't matter. It has nothing to do with these numbers. And let E4 equal no event. And now I'm going to match on them. Now, match E3. E3 will match on critical. So it'll match this critical. So, by the way, these matching statements force you to go through all of the options. You have to go through every single one of these when you do a match. You're not allowed to not do something. So here's normal, here's warning, here's critical, here's no event. I mean, you can do a underscore equals, we'll see an example of that in a little bit, to say anything else. But at any rate, so E3 should say critical, and my value is E3. And so E3 is critical. Event, E3 is critical. Now I'm going to let E equals E2 clone. Now these are, when I do this, matching here, this is a consuming operation. This is really getting passed by value into an internal function. So if I want to continue to use the event, I have to clone it. Or I could clone it here, it wouldn't matter. Okay. And that prevents this event from being consumed. But anyway, so let E2 equal clone if let warning. And next statement panics if event is no type. Let E3 equal unwrap. And so what we saw was where did my
Professor, I think you hit close after you run it, so I think you might have to run it again.
Okay. Yeah, thank you. I did. You're right. I did. So, event 3 is critical, event 2 is warning, inner event of critical is 3. And now let's just, we'll panic if you unwrap E4. Let's make it E4. Panic. Okay. Cool. So you can create your own. That's what I just did. I created my own enumerations and matching. Here is, you can match. Matching doesn't have to be on enumerations. You can match on other things. So here, I'm going to match on a character. Match, so my character is C, this do function. I'm passing in a character. Match on this character. 0 to 9, print out as a digit, A to Z, lowercase ASCII, capital A to capital Z, uppercase ASCII, and it's some other character type. And now I'm going to do it on these. Let's run it. So A is lowercase, Q is uppercase, Z is digit, alpha is some other character type. So this can be useful if you know about it. It took me, I probably worked with Rust for 5 or 6 months before I knew you could do this. Okay, I just assumed that it was the only example I ever saw was matching used on enumerations, and I assumed that's the only place it worked, but it doesn't. It works in these other places too. Options. So we've looked at this. You know, do iter, and I showed you this. We looked at this already. What I want to do is just go down here to this. There's a little demo for options with plugins, and I mentioned to you before that if you don't use the undying when you're using a trait object, you may have to use a lifetime annotation. So here I have a struct demo, and I'm plugging in an option, and I started out with none of this #A stuff. This is anything with a tick A is a lifetime. Rust reserves the tick argument to say what follows is the name of a lifetime. And it does, for all references, it does lifetime analysis. And usually without you ever doing any annotation. But there are occasions where it can't figure out whether the lifetime of, in this case, the lifetime of the plugin is going to be long enough. You know, will this plugin go away before demo goes away? Demo is the host. And so here I'm saying tick A is the lifetime of demo, and my plugin has to live for that lifetime. That's what this says. This says this value of the option has to live at least as long as demo lives. Remember, I'm going to plug in something from outside. And I start out with none for the option. And now here's my accept function. Here's how somebody else plugs something into me. Here's my accept function. I say self.plugin sum p, okay, where p is some reference to a mutable t. So that's my lifetime. So, and there are other ways around this. For example, in this example, what I did was now my plugin I'm plugging in the type by value, not by reference. And so what I'm doing is I'm just giving my host the ownership of the option. And now Rust is perfectly happy. I don't need to annotate any lifetimes because I gave him, by passing this in by value, I gave him that object. Does that make sense, guys? Fish task, does that make sense?
Yes, Professor.
Okay. Vaibhav?
Yes, Professor.
Okay.
Yeah.
Mike?
Yep.
Okay, good.
Thanks, Doc.
Okay, so an error handling, am I doing anything different here? Let's look at the playground example. We'll just do this really quickly. So here, the only thing different about this is I'm creating my own custom error. So here I say struct custom error. I'm not making this there is an error trait. I'm not making it implement that error trait because I'm not going to do anything fancy with it. I am implementing the display option for custom error just because I wanted to figure out how to do it. And basically, usually when you implement the display trait, you are using the standard IO write function to write it out. Now I have a function do no error, a result my custom error, okay. Do error prone result. So here I'm just going to return okay of nothing. My result is nothing, and so I'm saying I'm going to return a good result. Do error prone. I'm gonna just automatically return error. So do error prone always returns an error. Do no error always returns a good result of nothing, the unit. And now I just run them here. So this is just an example of defining your own custom error type. Again, where you might want to do that, if you have several different functions that have to handle errors and you're returning different error types, then you can't bubble stuff up to a single error handler in the calling function because they all have to be the same type. So you could just write wrappers around some of them to, to change their error type to whatever you need. Okay, I think we are about done. So next time, this time we talked about dirnav. Next time, I will show you my solution for dirnav, and we'll talk about command line parser. I'm not going to give you any help for command line parser other than I'm going to point out some references to you for the parser, and I'm going to tell you my design strategy for it, but I'm not going to give you any starting code for it. Okay. So that's it. So
That's really insightful.
okay, so do we have any questions, anybody? We all good?
Yes, Professor. So this is about the text search that we did, and I think so. The question I had at the beginning about the structure, I think you answered that with the I think it was the animation using errors and
okay.
options.
Okay.
So yeah, because when I implemented it, I used the file : open method, and that returns a result type. So I had to match on that to figure out if the file opened or I got an error. And so as I was writing code, I found that I wound up having nested matches, and I know that may be fine for a small example, but that's no good for large code.
Yeah.
So I was wondering if there would be an easier way to do that, because when I tried to use that reference outside, it said file ref may be possibly uninitialized. That was the error the compiler gave me.
Yeah.
And so while I knew that I was checking and that if I got to that point, it definitely would be a valid reference, the compiler just wouldn't let me do it because I initialized it inside a match.
Yeah.
So using bool flags didn't work. None of that worked. It was just telling me I may have a possibly uninitialized value. So I just wanted to figure out, what's a good way to get around that, because
You can bubble up errors. I did something a little funny in my text search. I said an error is not an error. What I said was, if I can't open that file, it doesn't have the text.
Okay.
So I sidestepped that, but one good way of handling that is bubbling up with the arrow operator. That gets you around those nested matches.
Yes.
It's very common. That the problem that you ran into, almost everybody runs into it at first, and then you start pounding it and say there must be an easier way, and usually there is.
Yes.
The try operator, the question mark bubbling up really works like a charm. Most of the time, you try to get things to work that way, and it may be that you have to put a little wrapper around it so that you translate the error into the error that the outside function is expecting.
Yes.
When you see my solution to dirnav, you'll see me doing a little more classical error handling, like you were doing in text search.
Okay.
But you're invited to look at mine. You can all you got to do is if you go to how can I get this up so you can see it? If you go to okay, so you see my homepage here now?
Yes, Professor.
Okay, so if you go to my GitHub repository, you don't have to go this route. There's I have some links directly there, but if you go to BuildOn to you remember we got to this link from the PDF.
Yes.
BuildOn 2 solution. You can just in fact, what you want to do is you can clone this BuildOn repository just like this. Now I have all the BuildOn code.
Okay.
It created a directory for me there and has all that code in it. So so it's easy to get to any of that code. That's why I put it all up on the repository, so you can get at it anytime you want to. And if we go back to that, if I can get back to it, I can't get back to it. So BuildOn code. Here you are, and this is what you're cloning.
Okay.
You're cloning this whole thing. You can't clone these individual ones. It'd be nice if you have, but I don't use Git. Git doesn't make it easy for you to have sub Git projects. You can do it, but it insists that they're really different repositories, and the outer one is just a collection of those links. Okay, so.
Okay, Professor.
Okay, any other questions? So, what's your feeling about Rust? So let's see if I can. How do I get this full screen again? Oh, I gotta unshare. Alrighty. So what's your feeling about Rust? What do you think so far? Fish task, what do you think of? So
it's nice. I like it. It definitely doesn't seem, as complex with as many moving parts as C++ had. But there are certain things that I just find tricky to do. For example, this was one of them. Well, doing the text search. So I think there is definitely a much steeper learning curve involved at the beginning, but I imagine as I get familiar with the language and how it works and how it's constructed, that would go away in the future, and it might be easier at some point down the line. But there would be a lot of work and study involved initially.
Yeah, yeah. I agree with you. To me, that initial, when you first pick it up, there's kind of a steep little step you got to climb. But once you're there, everything starts to fall. And for me, everything kind of falls in place. Click, 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 click. And I find it easier to write than I do C++. I love C++. I've written it, for years, but I really like Rust. How about you, Vaibhav? What do you think?
It is tough, Professor. I have to learn more, I have to read more about it and write some code. I have written something, but it is tough initially. But what you teach is way more useful than I can find anything on the internet for reference. So it will take some time for me, but right now it is tough.
Yeah, I know you're busy with the, job change and all that sort of stuff, but now is a great time. It'll be harder later on when you don't have people to talk to. Now you can send me or Mike or, any of the rest of us, Zing or whoever, on Discord, send them a message and,
sure.
questions answered and stuff.
Yeah.
You've been using Rust for a while, Zing. How do you like it compared to C++? Your sound is off.
Can you guys hear me now?
Yeah.
Yeah, so it's I really want to share my experience. So first of all, in this project, the Rust part is just a pieces of parts. So I just learn something, the basic syntax of Rust. I can write some code, but the logic goes more complex. I have to read the document. I think the online documents or online tutorial is very great. But you have to went through it again and again until you really understood the philosophy behind it. For example, Rust don't have those inheritance.
Right.
It doesn't have inheritance, but it has the document that it prefer composition instead of inheritance. But the real reason it have some explanations. But I think those explanations make sense. Makes so sense. So and except that Rust have other features module moduling the package, and also so those, I think the feature is almost the same. Async Rust also Rust have also very cool libraries, and also for example proc macro. I don't know, Professor, you use it or not. Proc macro,
Yeah.
It's also abstract syntax trees kind of stuff. You have write some Rust code to generalize Rust code.
Yeah.
So yeah, basically I think it's a very cool idea. And also a Lambda closure. The closure stuff is really the Lambda stuff in C++.
Yeah.
Right. So also the thread stuff, and have multi-thread pool, and also we also have a library I'm using is called Tokyo. It's event time. It's like a JavaScript event loop. It provides API like this. I think it's also very, very cool.
Yeah.
I really enjoying writing code in Rust compared with writing C++, because for C++ maybe it's easier to write the code because you don't need to consider about the memory stuff. It's easy to write wrong code. I read several times I write code, it works, but at runtime it's just aborted or just panic. I don't know why you have to use those debug tool, for example, GDB, or if you're using in a Linux environment, you have to use GDB to figure out what's going on. So so generally I prefer like writing code in Rust, but because you can deal, mostly I can deal with those kind of errors at runtime, at compile time.
Yeah.
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 Once you get comfortable with it, it seems simpler to me than C++. There's a lot of things. I think you said the same thing, that there's a lot of things you have to think about when you're writing C++ code that the compiler really takes care of for you. How about you, Arpit? How are you feeling about Rust?
Good. So yeah, I was just thinking about it. So I've been working on this project in my team. It's a batch processing project. At any point, basically, you enter around like 50,000 users data, and it goes through a bunch of like 15 APIs and then get the data and then combine them into one format. So I created this project with Go recently. And it would be really nice to see how Rust would compare to that, because I really like the concurrency model of Go. And it was better than the performance was better than Node.js. So that's why
Yeah.
But working with generics in Go, like it's a nightmare.
Yeah.
So something like Rust maybe would be a good alternative to that. So I'm gonna look into that definitely.
Yeah. Everybody that I have read who has a lot of Go experience, I don't, but have said when they move to Rust that Rust is faster, that Go's Go routines are nice, but they're slow compared to what you can do with Rust. So
yeah, it'd be good to see that. So I'm like, after today, like looking at the generics and all of that stuff, I think it should dial down the amount of code that I wrote in Go.
Yeah. How about you, Mike? How you doing?
You know me, Doc. I like it a lot, and I think there's little elements of what everybody has said, are the same case for me. It's some of the challenges of the newness of it, the similarities and differences to what separating the differences between the different paradigms and understanding how to go about doing things the right way in Rust. I get back to that initial learning curve, but I'm finding that I'm starting to get more comfortable as I look at more of your examples and I write code. It's much more intuitive and a lot less cryptic. And as we've talked about before, when I go back to some of the C++ code I wrote, I'm thinking about ownership, and I'm thinking about, do I need a copy of an object here? Right? I'm thinking differently about things in general.
Yeah. I know it's learning Rust has certainly changed the way. I will never write C++ in quite the same way again. So I will write more C++. I like C++, but all righty, guys. I think we've covered the ground. So everybody's still up for a meeting in 2 weeks?
Yes, Professor.
Yes, Professor.
Yes.
Okay. So we'll do DIRNav in 2 weeks. So we'll let's see. I will put my solution of DIRNav up in 2 weeks, and you will do your solutions for DIRNav in the meantime. And then I will spend time. I'm going to talk quite a bit about some parts of iterating. Mostly I'm going to spend a lot more time talking about the adapters, the iterator adapters that Rust provides, because they can be useful for the command line parser. So, and I want to talk to you a little bit about the philosophy for designing the command line parser. The idea is to make it as reusable as you can, and clearly that means there's two parts. There's the part that's completely reusable, that's just handling how things are parsed, and then there's the part that says these are the attributes that I need for this application. So we'll talk a little bit about that next time.
Professor, I just remembered that I will be traveling in 2 weeks and connectivity will be really limited, so I may not be able to attend
Okay.
if it's 2 weeks from now.
So what's your travel schedule? If we did it half a week later, would that work?
Yes, I'll be returning on the 31st. So I'm leaving on the 23rd and getting back on the 31st.
Okay, let me pull up my calendar here.
Hey, Professor, I need to be somewhere at 4, so I'm going to leave.
Okay.
Time for the session.
Sure.
Thank you.
See you later. See you next time.
Bye.
Professor, I am also dropping.
Okay, hang on 1 second. So, Vishtap.
Yes, Professor.
You said that you're going to be traveling. You'll be back. Are we talking about? There is no 31st. I'm on February's calendar. Okay, so you're coming back on the 31st. When are you leaving?
On the 23rd.
Well, I wouldn't mind either doing it on the 18th or doing it on the 1st. You guys have any preferences if we did move it a week? Would you prefer the 18th of March or would you prefer the 1st of April?
So, Professor, do you mean to do it on Fridays or Thursday?
I meant on, so it would be Friday the 2nd.
The 2nd works for me.
How about you guys? Would you rather do the, will that work okay for you? Or the other option is to do it on the 19th? A week from today.
Those are both fine for me, Doc.
Yeah, both are fine for me.
Okay.
Both work for me too. If folks want more time to work on the project, I imagine the 2nd, but I'm fine with the 19th as well.
Okay. Zing? Do you have any preference?
I'm mute. I think it's okay. Both works for me.
Okay, then I think we'll tentatively plan it for the 19th. 3 weeks is a little long between the two. And I don't think the DERNAV is that complicated that it'll take a whole lot of time to do. So
if you did it in the 19th, Doc, then we'd be back on schedule for 2 weeks later to do it on the 2nd again. So
yeah.
that'd be.
Yep.
All right.
Yep. All right, I'll put it on my calendar for the 19th. If any of you change your mind, let me know, and we'll do something else. But
okay.
Okay, guys, terrific. Thanks for being here, and we'll see you next time.